Everyone, and welcome to the series on computers, on Python, and on data science. In this video, we're going to continue Module 5, which is over Pandas, and we're almost done. We only have like 2 sections, so this might be a quick video, depending on how easy this goes. So with that, let's get started. So we're going to talk about indexing in a data frame. The time has come to finally try to retrieve the data necessary to complete the task set up by the Yandex Music Manager. In order to do this, we must understand how to request data from specific cells in a table. We can refer to a cell with data in the data frame by its index and the column name. Depending on how we formulate our query for the data frame, we can retrieve different slices of data. This process is referred to as indexing. There are many different ways to index a data frame. The lock square bracket row comma column attribute lets you access an element according to its row and column. So you can see they do df, which is the table name, dot lock for in genre. So you get the fourth column with the row genre. And they give you variations on it. You may have noticed that the request of lock square brackets attribute uses square brackets, leading you to think of a Python list. Indexing a data frame is similar to indexing such a list. Remember the classic board game Battleship? In order to win, you can't just shoot wherever you feel. You have to think of how your opponent's battlefield is set up and if you want to sink your target. Look at the Battleship playing field. It's similar to a data frame. There are columns with letter designations and an axis of indices. Notice the difference in indices. In the data frame, they go from 0 to 9. Okay, the data frame cells with 0 value represent empty cells. The value in a cell changes to X if a player shoots and hits an opponent's ship. If they miss, it changes to a dash instead. Let's examine the current situation on the playing field. Take a look at column C. We can see that an attack on a ship has started in this column. Indeed, an attack has begun in the 6th row, but the ship hasn't been sunk, and the shots fired at the squares above and below have both missed. Let's try to take a closer look at the entire 6th row and discover the ship's position. The ship is oriented horizontally, and 2 successful shots have hit it in columns C and D. We need to assess the situation around the ship. Look at rows 5 to 7. It looks like the next shot should be fired at 6E. Hooray, we've sunk the battleship. Now our aim is to locate the second triple-decker ship. Okay, and they're just going to play around with accessing different things on the field. Important note, when we use slices and lists, the very end of the slice isn't included in the output, but the dot lock attribute stands out in fact that it includes both the beginning and end of a slice. For example, here's a list of artists. Elements 2 to 4 be returned by this request. The last index in the request is 5, specifically because we wanted to include the element with index 4. The request to get rows 2 to 4 in the table would look as follows. So you can see instead of going to 5, they go to 4. Now you've seen how to request one column, one row, and a range of columns and a range of rows. These are the most common requests we will make as a data analyst. In practice, a short notation is often used for indexing, although its capabilities are limited. Bear in mind that it doesn't always return the same results as the .lock attribute in its full form. Holy cow, there's a lot of description. I think we're just going to, again, this is like I did in an earlier thing, is they have so much description here that it's easier just to do the example, and you can do by frame if you want to go into more description. Okay, make a table comprised of the genre and artist column saved to genre fight variable. Okay, so we want a new table called genre fight. And it's going to be a pd.dataframe where the data is going to be originally an empty list and the columns are going to be equal to genre and artist. Okay, so let's see if that's what they're looking for. Okay, so maybe they don't want it to be a data frame yet. Maybe they only want it to have the list of lists. Okay. Maybe they don't want... Let's see if we scroll up here if it'll tell us. So if we don't specify the data, we just specify columns, if that's maybe what they're looking for. Genre and artist. Maybe they didn't specify, but they actually want the data to be DF. Yes, they didn't specify that, but we just had to add DF as the data. Okay. Count the exact number of times tracks have been listened to in the pop category. In order to do this, you should use the logical notation genre fight genre equal pop. Save the result to the genre pop variable. Okay, so genre underscore pop is going to be equal to df. I guess we can do genre fight dot lock, where I think we do genre equals pop. That's not how you do that. Let's see. Yep, so it's something like this here. Genre.lock. We want all rows, and we want the genre column, and we want that to be equal to the pop. Okay, so let's just print what we get when we do that. Okay, and then we want to count that via so we have dot lock, and then we have the equals, and then we access the I wonder if we can just do dot count. I think that's giving us all of them, but we will actually want it to be true, right? So I also didn't hit next. Okay, so genre pop is going to be equal to genre fight dot locate. We want all rows, specific column genre is equal to pop, and then save the result to genre pop, then print your okay, and we want this located at you should actually do it twice. So genre fight dot lock equals pop, and then now we access the genre category and we get its count. Okay, and then we print the number of listens in the pop genre is, comma, genre pop. That seems about right. I think I have an extra space in there though. So let's check that. Correct. Next. So let's build up the code further and calculate the number of listens to tracks in the rock genre at a count that differs from the previous one in that it has a logical condition df genre equals rock. Save the results to a variable genre rock. Don't delete your previous print commands. Print your response like this. Okay, so we should be able to copy paste here. Let's kind of organize these in their own sections though. Okay, genre rock is going to be equal to genre fight equals locate, where the genre is rock. We also access the genre category again, we get its count. So the number of listens in the rock genre is genre rock. So let's play that. Check it. Awesome. Okay, so now we need to write a conditional. Let me hit next real quick. Now we need to write a conditional statement that compares the values obtained in the previous tasks and outputs information about the winner of this musical battle. Don't delete your previous print statements. If rock wins, output the message rock wins. If pop wins, pop forever, I guess. Okay, so we can do if genre pop is greater than genre rock, print pop forever, else print rock wins, exclamation point. Correct. Next. The series object. Every column in the table we've been examining throughout the previous lessons was not a data frame. Data structure. Surprise, let's check. The table is a data frame. But if we take the individual column of the table, it will have an entirely different data structure. It's called a series. Now let's examine some peculiar qualities of this new object. A series is a one-dimensional table, and you can pull elements from it by indexing. Each index is the number of a single observation. Several different series connected together produce a data frame. A series stores one type of data. Every series information about the amount of data in the column and the data type stored in it, D type. Print.
Sorry.
Let's see, sorry, Siri is going off. We want to. Every series has a name, information about it, and the data type stored in it. Okay, df artist. They show you the indices and all the different rows. Not all of the data in the artist column is an object. There are some missing values, not a number. We'll talk more about these values in the chapter devoted to garbage data. Counting these missing values, the column length is equal to the total number of observations, 67,963. Indexing in a series is comparable to indexing elements of a single column in a data frame. Let's take a look at an example. We'll try to save the total play column to the total play variable. In order to obtain the element at index 5, we put 5 inside the square brackets. If you need to get a range of cells, request the lock attribute with the slice boundaries inside the square brackets. Here's a table with different options for indexing in a series with included short forms. Boolean indexing is also possible with series. Let's take a look at an example. If a user doesn't like a song that starts playing, they hit the next button. Then a very brief listening time is saved to the table from 0 to a couple seconds. You can check how many users decided to skip a song within a few seconds, no more than 10 seconds from when the song began. In order to solve this problem, we'll use the logical condition total play is less than or equal to 10. We've chosen the 10-second inner or threshold arbitrarily, but it could be interesting to figure out if a threshold time actually exists, an amount of listening time after which a user is most likely not to skip a song and instead listen all the way to the very end. Data analysis lets us ask such questions and find answers to them. Let's go back to the competition between rock and pop. You were suggested to determine how many songs in the genre were listened to for less than 5 seconds and whether the time frame at which users decide to skip songs is related to the genre. Are there perhaps any other factors affecting the statistics? Retrieve a table with only the rock genre and save it to the variable rock. Okay, so rock is going to be equal to df.locate all rows, specifically the column genre, and we want it to be equal to rock. Okay, and then we're going to access this from the table we already have. Okay, so let's print what we get when we do that. So you see we only have rock genres now, and it's still a table. It's got all the different columns in it. Okay, so let's check that. Correct. We'll separate listening times for rock tracks in a specialized data structure. Save the column total play from the rock table to a variable rock time. Okay, so rock underscore time is going to be equal to rock total play. So we should get a column with like 134 in it. Let's print that to see if we get that. Yep, so we got 134 as the first one. Oh, I forgot to hit next, sorry. So we're doing rock time is going to be equal to rock at total play. So we'll check that. Correct. Next. Refer to the new series with the name rock time and calculate the number of rock tracks skip within 5 seconds, specifically rock time is less than or equal to 5 as a logical condition. Save the result to the variable rock haters and print it with the explanation. The number of rock tracks skipped is... Okay, so we'll do rock time less than or equal to 5. And we're going to grab that from the rock table. Potentially we need to do lock here. Let's see. See, the total play here is 3.6 seconds. All these are less than 5. Let's see, I'm wondering... So we need to call count on this. I'm wondering if it wants us to store it in rock haters or not. But we'll try this. Print the number of rock tracks skipped is comma rock underscore haters. Hit play. So we need to do some accessor here. We could basically do user ID or total play or genre. They're all the same. Check that. Correct. Next. Only select the rows containing pop genre from the source table and save the new table to the variable pop. Comment out the output from the previous task. So we comment this out. Then we do pop. We basically are doing this same thing. So we do pop is going to be equal to genre pop. Check that. Okay, next. Now in the same manner, create a series that only stores data about playtime for the pop genre. Call it pop time and save the data from the total play column of the pop table to it. So we're basically just copying and pasting this rock code. They could have just said that. Pop time is going to be equal to pop total play. Correct. Next. Again, use a series as you did with the rock genre. Utilize pop time to find the number of pop tracks skipped within the first 5 seconds. Use the condition pop time is less than or equal to 5. Save the results to pop haters and print as follows. So we have pop haters is going to be equal to pop.locate. Pop time is less than 5 at genre, get the count of it, and then print the number of pop tracks skipped is pop haters. Okay, so we check that. Correct. Next. For both genres, calculate the percentage of tracks that user skipped right straight away. Divide the number of tracks that the user skipped rock haters and pop haters, respectively, by the total number of rock and pop tracks. The total number of tracks in a genre is equal to the number of instances in the rock and pop tables, or the value of the shape 0 attribute of these tables. Save the results to the variables rock, skip, and pop skip. Print the values of these new variables as percentages, precise to 1 decimal place, like below. Comment out the output from the previous task. So we comment this out. We make a new variable called rock skip, and this is going to be equal to rock haters divided by rock dot shape 0. Okay, and pop skip is going to be equal to pop haters divided by pop dot shape 0. Okay, and now we need to print both of them, so print percentage of rock tracks skipped, colon. Then we need to do the formatting we did before, which is squiggly bracket, colon, dot 2f. How many decimal places? 1 decimal place, so 1f. Okay, and we're going to print, or dot format, rock skip. It also wants a percentage, so I think instead of doing, I think we do percent dot 1f. Okay, so let's copy and paste this for pop. Let's play, see what we get. Have my formatting code here wrong a little bit. Let's try and figure it out. There we go. Seems about right. We'll check it. Correct. So you see they're pretty similar. They're close to 33.3%. By combining essential Python knowledge, print and format with certain features of Pandas, you already reached a significant milestone for real-life business. It's vital for completion of the tasks that has been set by the Yandex Music Manager, increasing listening time. The conclusion of our investigation is counterintuitive. As often happens with data analysis, it would appear that since everyone loves pop, you could increase listening time simply by adding more pop music to playlists. But unfortunately, that's not the case. Although people do listen to pop more often, they skip it just as often as they skip rock. Yandex took a different approach. They merged the music and radio services together. Now you have to evaluate the outcome of this experiment. So what's next? Before we tackle the vast table the manager provided us with, we'll need to clear out missing values, duplicates, and other unwanted artifacts. An important decision must be made. You can't let garbage data lead you astray. Pre-processing data is so incredibly crucial that the entire next chapter has been dedicated to its methodology. Okay, so with that, that's the end of this module. So I thank you guys for watching. I'll see you next time.